This is Note Taking Guide 5.7 for Math 1. Today we're going to talk about simplifying square roots, cube roots, any kind of radical really, and even just punching them in the calculator and finding out where they would be on a number line. So this first problem right here says to find the square root of 121. Now there's a couple of ways that we can do this. I want to remind you that if we have the square root symbol like this, then really what that tells us is that there has to be two of the same number underneath there. So for instance, if we were finding the square root of 25, the reason that that gets to come out as 5 is because 5 times 5 is 25. And because there's two of them, I get to bring it out of the radical as just the number 5. So we can look for perfect square numbers underneath a radical, or we can do what we would call a factor tree to factor it and see. But on 121, I happen to know that 121 is 11 times 11. Again, to come out of a square root, I have to have two of something. Because there's two 11s, it gets to come out, and my answer on that would just be the number 11. So again, a square root means you have to have two of the same thing multiplied together in order to bring it out of the square root. So on this next one then, where this is a cubed root, in order to bring something out of a cubed root, then I would have to have a perfect cube number, meaning there has to be three of them. So for instance, if I were just going to do the cube root of 1, because I know that 1 times 1 times 1 is 1 still, I know that there's three of those and they get to come out as the number 1. So what I'm going to do now is I'm going to see if I can find the number that times itself 3 times would give me 125. Sometimes the best way to do it is to just go through my numbers. So 1, 1, and 1 multiply together to be 1. 2 times 2 times 2 multiply together to be 8. 3 times 3 times 3 multiply together to be 27. 4 times 4 times 4 multiply together to be 64. And 5 times 5 times 5 multiply together to be 125. So I just found the numbers that will work. 5 times 5 times 5. There are three of them, so the square or the cubed root of 125 is the number 5. So again, this was a cubed root. This little number right here in the crevice tells me how many of that same thing I have to have in order to bring it out of the radical. All right, square root of 36. Now again, you guys, I can do this two different ways. I can look at it and I can say, let's just do it this way. I know that 36 is 6 times 6. I know that there's two of those, so it gets to come out as the number 6. I could also do it another way, and I could think of my perfect square numbers. I know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. So if I just make my list of perfect square numbers and then I count them, this is 1, that is 2, here's my third one, 4, 5, and 6. My answer is going to be 6 on that because 36 is 6 times 6. So just a couple of different ways to look at it. All right, so this one says simplify the square roots. So when we did this before, we had them come out perfectly. Now 216 is not going to come out perfectly. So what I want to do is I want to think to myself, well, what numbers can I multiply together to be 216? And I want to think about it as those perfect square numbers, 1 and 4, because 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so forth up the ladder here on our numbers to get perfect square numbers. So I want to know if any of these perfect square numbers can multiply something to be 216. Okay, so like I said, we're looking for two numbers that will multiply to 216, preferably using one of those perfect square numbers up there. So I'm going to start kind of big, and see if 216 is divisible by 64. When I divide by 64, I get 3.3, so that doesn't work. I don't think 49 is going to go into it, but let's try 36. So 216 divided by 36, oh, it's 6, so that worked. So I can actually come here and I can say 216 is 36 times 6. And then I still have that k to the 4th, which is actually k times k times k times k. So when we're looking at this 36 right here is 6 times 6. So it gets to come out of this radical as 6. But this 6 right here has to stay underneath the radical. And then I get to bring out my k's in groups of 2. So how many groups of 2 are there? There's 2 groups of 2. So I have 6k squared, square roots of 6 for my answer on simplifying this one. All right, same thing on this next one. The first thing I want to do is identify my perfect square numbers to see if I can find one in the number 45. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Oh, I think that 45 is divisible by 9. So let's write that out with a 9 in it instead and see what we get. So 9 times 5 is 45, and then p squared is p times p. So this actually makes this simplify quite easily because this 9 right here is 3 times 3. It gets to come out as a 3. The 5 has to stay underneath there because it's not a perfect square number. And then I have to bring the p's out in groups of 2. I have one group of 2 there. So I have 3p square roots of 5 for my solution. Now, anytime it says simplify, it usually means we're not going to come out to one nice pretty number, so they usually can expect to be ugly. Sometimes I think even this answer, or simplified, is uglier than the way we started out. All right, one more example of this kind. So we have 2 times, or 200m to the 4th n. I was trying to tell you already that I was going to go 2 times 100. Because I know that 100 is a perfect square number. I haven't written it down on my list yet, but 1 times 1 is 1, and then 2 times 2 is 4, 3 times 3 is 9. And if I get all the way up to 10 times 10, 10 times 10 is 100. So my brain automatically went to 100 there. I know that I'm going to have 4 m's, and I probably don't need to keep writing these out. I know there's 2 groups of 2 in those, and then I have an n underneath that radical still. Then 100 gets to come out as 10. The square root of 2 has to stay underneath there because it doesn't have 2 of them. I get to bring out 2 groups of m's, but that n has to stay under because it's all by itself. So this is my solution right here to simplifying the square root of 200m to the 4th n. All right, this says round to the nearest whole number. So really, you guys, all I have to do is think about where this is going to be in between. So if I went back to my list of numbers again, I know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36. Now, if I were thinking about, again, that's 1, 2, 3, 4s, 5s, and 6s together. If I'm going to find the square root of 32, I know it falls somewhere in between 25 and 36, which means it's going to be either 5 when I'm rounding it, or it's going to be 6 when I'm rounding it. So I can really just punch it in my calculator, though, and do the square root of 32 on my calculator. When I do that on our calculators, it gives us 4 square roots of 2. And then if you hit those double arrows that are right above the enter sign, it will tell you that it's 5.65685, and it keeps going on. So was I right? Was it between 5 and 6? I was. The question is, it says round to the nearest whole number. Which whole number is it closer to? Because it's 5.6, it's closer to the number 6. So I'm going to round to the number 6 for my solution there. Okay. All right, let's try the next one. This is the cubed root of 181. Now we can punch this in our calculator too, but again, if I wanted to try to make a list of numbers to think about, I would go 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27, and I would keep going until I found what numbers I think would work for getting close to 181. Now on my calculator, I can punch this in my calculator and have it spit out a number to me. If I wanted to keep going on my list here, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, and 6 times 6 times 6 is 216. So I know just from doing this math that I'm between these two numbers, which would be between 5 and 6. I just need to know which one it's closer to. So I'm going to punch the cube root of 181 in on my calculator. When I do that, to get a cube root, I'm going to punch the number 3 in first, and then I'm going to have to hit my second key, because the key that I need to hit that looks like this, it has X and then a root like this. It's a green key, so it has to have the second key to hit it. So I do 3 second that key, and then I put in 181 and hit enter. When I do that, it is going to tell me what the value is of the cube root of 181, and I got 5.6566. So I was right. I knew it had to be between 5 and 6. The number that it's closer to, because of the 6 right here, again, is the number 6. So completely different problems, just the same answer on those two. All right, the square root of 96 to the nearest hundredth. So, oh, and maybe I should have checked. I didn't check to see if that last one said to the nearest. Oh, see, I should have rounded it different. This one didn't say to go to the nearest number. It said to go to the nearest tenth. So I didn't round that right. So if I'm going to the nearest tenth, the 10th spot is that first one past the decimal point. It's 6 and the one behind it is 5, so it will actually round up to 5.7 if we're going to the nearest tenth. So make sure you're reading your instructions. This time I'm going to the nearest hundredth. The hundredth spot is 2 decimal points past your decimal. When you punch this on your calculator, it gives you that 4 square roots of 6. Hit the arrows again, and it gives you 9.7979. We're going to the nearest hundredth spot, which is right here. That is going to have to round up because of the 7 behind it. So I really am going to get 80, because this will round to a 0 and make that round to an 8 automatically. So there's my solution, round to the nearest hundredth. All right. These last two say place on the number line where they belong. I'm going to go the square root of 42. Again, you guys, if I wanted to think about what two numbers it would be in between, if I went 1 squared, I'd get 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, then I'd go 36, and then I'd go 49.